Hello, friends. Good evening. Welcome to Eason Academy. Now we are discussing about C programming. Now, as a part of it, we are discussing about C language, and this is session one. Once again, I request you, if you have not added the WhatsApp number, please add it onto your contact list, because when I send the WhatsApp group message, broadcast message, then only you will get it. And anytime you can contact me on the WhatsApp or email or anything. Now, on the C language, we are going to discuss about very critical one, that is called allocation. That is what the part today. What is C language allocation? It's normally we don't think this about serious, but this plays a very vital role when you're writing programming. Sometimes you get confused. People ask a lot of doubts. So that's the reason I thought I'll spend some time on this allocation today. Okay, please. Let us move to the board as usual. Okay, so this allocation is a very simple topic, but it's to be understood very clearly. Nothing more than that. Why it is required. So when you write a program, I have told you that when you give it to the computer, you say get A. Now, when you say get A, I told that is in a memory, a small space called A. That it is going to get from your keyboard and store it here. Then you put get B. Then from here you get B and put it on B somewhere. So each one is stored at some location in the memory. But you don't worry. For you, you do not worry where and what. The thing is that this guy, the computer puts that thing. You have to write only this. You don't worry where the A is there, where the B is there. That is not your botheration. Then you say A plus B to C. That's it. Add these numbers, then store it here. So this guy is having a tight relation. Who? Your computer and your memory. So forget about it. I'm not using the word CPU and dot. So I want you to understand. Now I'm not explaining about computer architecture. I'm explaining about programming. So concentrate only as a programming as a kid. Don't too much think. This is what CPU, microprocessor, the RAM, and no. I'm not worried about that. I don't use any of the thing. So this is simple. But the problem happened was this. You have to think about so many years back, about 50, 60 years back. All right. Those days, 1 kilobytes. Today you have, for example, your pen drive of 32G. That means 32 followed by this many bytes. Cost you 200 rupees. That is so cheap. But those days, even a 10 megabyte, that is 10 followed by 6 zeros. This many bytes. There is how many times less? You see here, 7 zeros. Track the 7 zeros. 30,000. You know, it's costing about crores. Costing about crores. So IBM's 10 MB was crores. And it requires 10 MB requires a big vehicle to ship, not like you carry in your packet SD card. Not only pen drive, even think about SD card, micro SD card. Nowadays, micro SD card, even 1 terabyte, that is 1000 G has come, 1000 gigabyte has come. That is because of see, at the end of the embedded system programming, you should be thoroughly understand these technologies. Am I right? But our motto is not only just knowledge. Our motive is very clear. Gain the skill and get a good job. If you want knowledge, I can give you all the 25 years or 35 years of knowledge I can transfer to you. But that is next. That will give you happiness. I've learned everything. But the one which is going to give you a job is a skill. That's why I'm going very slowly and trying to balance the knowledge with a skill. Now what happened? If we say get A, this computer allocates a space on the memory. Very unfortunately, he got confused. What confused? How big allocation? How big? Okay. How big in this case is here? Normally, when you build a house, we call one ground or two ground or four ground. Am I right? This is the way we use in the real estate when you build a house. One ground means normally, let us assume that 60 feet by 40 feet. That means that 2,400 feet square feet. Am I right? This is called one ground. Or sometime you hear this terminologies. 1 BHK. 1 bedroom, 1 hall, 1 kitchen. 2 BHK. 2 bedroom, 1 hall, 1 kitchen. 4 BHK. 4 bedrooms hall. That's so. If you want to construct a big house, then you have a bigger space. If you want to construct a smaller house, you want to have a smaller space. Like that. Here, what they have done was, since the memory was very expensive, our man, great man, Dennis Ritchie, said, you say get A, that is not sufficient. You tell me what is the size of the A? Size of A. How much you want me to allocate on the memory? What's the size here? Very small trick here is whether it's a 1 byte or 2 byte or 4 byte or nowadays 8 byte. Okay, 1 byte or 2 byte or 8 byte or 4 byte. That's simple. So what you have to do here, before you using get A, you should tell him that I want to use 1 byte A. If without you telling him, if you start using that, the computer will say that no, I don't accept this because you have not allocated any space for A. Okay, in his language, Dennis Ritchie language, they call that as a declaration. We think they are very simple, but actually they play a very vital role. That's why I'm telling you now. Okay, I'll tell you that you will understand it why I'm explaining these things very slowly. So please understand, if you do not allocate, then you cannot use it. That's a clear. But other language, for example, Fortran, Python, these languages, you do not allocate, you can directly use it. Okay, but on C, you need to allocate first. But this allocation is called, declaration. The allocation is called declaration. That means that, for example, you first write it. Get A, get B, A plus B, put it on C. put C. You written a small 4-line, right, program, but you're using A, B, C. You should decide here whether you want. I'll tell you that what is the difference between 1 byte, 2 byte, and 4 byte. I'll tell you now. You have to say now, initially 1 byte, A, comma B, comma C. Then he will understand, oh, good. So A, B, C, I allocated. Now we come to the very important point. What is called 1 byte? Okay, now you have to know a little bit about binary and decimal. If I say 1 byte means 8 bits. If you say 8 bit means I have 8 locations. That means that I can store any number here. In your decimal, if you put the 8 digits, you can store maximum 9999. That means how much? 9 crore, 99 lakh, 99,999. Here, all will be 111 in binary because you have only a 0 and 1. 0 and 1. So we store all 1. But the beauty is, who understand this? Our computer understand this, but you don't understand this. If I write this, you think it's 1 lakh, 1 crore, 11 lakh, 11,111. No, it's not. It is actually, this is, you would have studied in the colleges, schools. Base 2, which is equal to 255. How I got it? Let me tell you that. Very simple. Please understand, which most of you may be knowing that. 1, the first one is 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Because 0, you start from 0 up to 7, 8 bits. So if all of them are 1, means it is quite simple. 1 into 2 power 7 plus 1 into 2 power 6 plus 1 into 2 power 5, 1 into 2 power 4, power 0. It's about 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So don't worry about that. I will share a video about number systems today. After the class, I'll share a video in our folder. Please walk through the number system video. Okay, when you walk through the number system video, you will understand about all these binaries and everything, which is there. So let us assume that like this. In a memory, every line is occupying 1 byte. That's why you say that always your hard disk capacity is 500 GB. Your main memory, that is RAM, you say that 8 GB. Your SD card, you say 32 GB. All these B's are all bytes. We always talk we measure all the memory capacity in terms of bytes. Byte is a standard here. Like a liter, like a kilo, here the standard is byte. That means that in one line, I can store 8 bits. I can store 8 bits. That's it. Nothing more than that. So I can store a number. The lowest number is 0000. The highest number is 111. So if I say that 1 byte A, B, and C. That means that I told the system allocate A, B, and C. All of them are allocating 1 bytes. That means that you cannot say now, I want to store now 26 to A, 95 to B, 300 to C. The problem is when I say 26, you know this is 1, 2, 4, 8, 16, 32, 64, 128. 26 means 16 plus 8, 24 plus 2, 26. So I get 0, 0, 0, 1, 1, 0, 1, 0. I share the number system videos by today. Before coming to the Thursday class, watch the number system videos and understand this binary operation thoroughly. That will help us a lot. Okay. If you know that, is fine. So see, when you go from Chennai, India, whatever it is, to German, please understand, you have to learn German. You can manage with English for some days, but you have to learn better German. If you go to France, if you go to China, you better learn with Chinese. You go to Korea, you better learn with Korea. Same way, now you are going to the world of computers, which are using only switches, 0 and 1. So please understand, the more fluent you are at binary, the more fluent that you are binary, that will make you to understand that. So this is the only thing. There is nothing. You say, if I say 255, what is the binary? Small numbers, not big numbers. Now you see here, now when I say, so what is this is 001, 1010. Stored. But now do here, same thing, 95 to B. 95 means what? 64 plus 16, 80, 88, 92, 94, 95, 0, 0. That means that this number is stored here, 0, 1. But now you have written 300 to C. That guy got confused because the maximum, if you put all 1, you get 255. You cannot store 300. This is wrong. You cannot do that. Understand? This is all about your C language. Basically, allocation first. So if you wanted to store, either you do two things. If you allocate a byte, then you cannot store more than 300. If you say 1 byte, ABC, you cannot allocate more than 300. But if you wanted to allocate 300, then you remove C from here. Then you say 2 byte. When you say 2 byte means he will combine 2 bytes for C, not only 1. That means 8 plus 8, he gets 16 bytes, 16 bits. He gets 16 bits. Understand? So it goes from 0, 1, 2, 4, 8, 16, 32, 64, 128. Then 256, 512, 1024, 2048, 4096, 8192, 32768. It goes such a big number. This is 2 power 0, 2 power 1, go to 2 power 15, because this is 16 bit, because you allocate 2 byte. So the maximum number will be 65,535. So basically your allocation means how many big number you can store. If you can say 1 byte or 2 byte or 4 byte or 8 byte. If you say 1 byte means 8 bit. If you say 2 byte means 16 bit. 4 byte means 32 bit. 8 bit means 64 bit. Okay, there's a small confusion here. The confusion was this. Unfortunately, he thought, our man, Dennis Ritchie, this may confuse people. So what he said was, he has given a different name. He called this as a CHAR, 1 byte. And next one, he called this as a short integer. It's actually called character. I'll explain to you what is integer next. Then it's called long integer. This is called long integer. This you might have never heard this char int. Actually, it's called 8. He didn't use the int word, but it's actually an integer. Now, let us think about now the storage. There are 2 types of numbers are there we have. One is called integer. Other one is called fraction. The top level is real number and imaginary. Forget about imaginary. We talk about the real numbers. In real, there are 2 types, integer and fraction. The integer means, okay, it is a whole numbers. Whereas fraction is, it's have a decimal. Okay. So, Dennis Ritchie has given a 2 options. One is integer he called int. Unfortunately, fraction he called float. I'll explain to you what is float later. That is called float means other opposite is fixed. I'll explain to you why he called the fraction as a float. Okay, let us not worry about now. Now let us worry about integer. Now integer has about natural numbers and negative numbers. Okay, so integer has minus from negative, minus number to plus negative, including zeros. That's what you call integer. So here minus 128 to plus 127. That's what you can store. You cannot store any other thing. That means that you cannot store, you cannot say char A. Then 75 to A is fine. You cannot say 128 to A. That does not work. This does not work because it's wrong. Don't use that. Don't try to deviate the rules. Follow the rules. If you say char A, your number has to be only this much. If it's a char, if it's too short, then minus 32,768 to plus 32,767. This is all about storage. That is, don't worry about. These are all. If you feel that is a confusion, forget it. We'll do it later also. That's the way. That's the way you should be able to think. Anything you get confused, don't try to get in too much. We'll discuss once again. But you have to give first priority is your first priority has to be C programming. Then only your C language priority. I'm giving you a language because I want you to know that what is these things. That's why I'm giving you the idea. But if you feel it's very confused for you, now same way, 4 byte. Now if I say that, if I say that short A, then I've written now 798 to A. This is right because it is less than this. But if I say 42,768 to A, that is wrong because that is out of this range. Never do that. Same way, when I have a 4 byte, My number is minus, see that, so how big number is? Such a big number to plus, so big. You can go up to this number. That is how many digit? 9 digit. You can go up to 9 digit. Don't worry about if you use the long. I'll tell you another confusion. There is sometime you'll be using only int. I'll give you the confusion. What is the problem with the int? Of course, nowadays they changed everything. Nowadays they've changed all these things. I'll tell you what we use nowadays. Nowadays we call this as a char, as int 8, short as int 16, long as int 32, long as int 64. This is what we are using. See, let me tell you one more important thing. This is the grammar. This is the grammar. Okay. Always, we don't like grammar. Even the schools or colleges, we like literature. Okay. People talk anything, we do everything, but we don't like grammar. Why we don't like grammar? You know that? Anybody can tell me why we don't like grammar? Why we don't like grammar? Yes, char is a int. I will send you the document by Dennis Ritchie. Char is a int. It is not, it is an integer. Char, char is an integer. Please, if you don't know it, correct it. It is an integer. As per the Dennis Ritchie, not me, as per Dennis Ritchie, okay, integer has 4 types. Integer has 4 types. 8-bit, 1 byte, sorry, 8-bit, 16-bit, 32-bit, 64-bit. 8-bit is called char. 16-bit is called short. 32-bit is called long. 64-bit long. Just because he called char, people think this is a character. No, this is perfectly legal. Okay, I will share the screen maybe at the end of the session sometime. I will share the screen and show you the thing. Okay, we can see that. I'll write a program and see that. Okay, maybe the final 5-10 minutes. I'll do that everything. So please understand, everybody. Don't forget that char is an integer. It is not so. This is acceptable. That means that I can say here char or x, and I put x is equal to 45. This is perfectly valid. This is perfectly valid, and this is c. char is an integer. I'll tell you that where our Dennis Ritchie has mentioned that. Lot of students in our coming from college have this confusion. They think char is a character. No, it is an integer. Please. That's why I've written I written the word here, char int. That's what I've written here, char int. Please. Thanks. You have, at least I told you now. Sometime you said that how can char become an int? Your question. I told you. Some of the other participants also may have the same doubt. How come I've written? They did not ask. You have asked. That's a great thing. That's a perfect thing. We make everything very clear to you in coming days. Okay. Now the same thing here. When I say here long, I can show such a big number. You see that 8 followed by how many zeros? See here, up to plus such a big number. So you should decide that how do you store these numbers? That's a trick. How do you store the numbers is a trick. Do you want to store small numbers or big number? That is the way you should allocate. Okay, so this has to be your brain very clearly. But normally while programming, while you're learning program, don't worry about all these things. These are all when you go to the deep next level. But while you're doing programming, generally use int. What happened? Normally, if you use int a, there's a confusion. This is called 16-bit or 32-bit. But nowadays, most of the computers take int means 32-bit. This is only the old compilers. And I'll tell you some swear it takes 16-bit. I'll tell you later. But nowadays you can assume. But I request you to use this long or short char, but you can use int also, nothing long. But all of them are integer only. All of them are integer. Char int, short int, long int, long int. But I told you this is minus 128 plus 127. Okay. If you want to have a whole numbers, then you can do the small thing here. If you put a word before this char, if you use the word unsigned, if you don't put anything, it is signed. If you just don't put anything, it is signed. If you put a signed word, unsigned, char, then the value changes. The value changes from 0 to 255. This will give a whole number, not any more negative numbers. If you put unsigned short, then the same memory holds from 0 to 65,535. No negative numbers. So don't do this. Don't do that. You say that unsigned char x. Do not move 75 minus 75 to x because you have given unsigned. How can you store minus 75? Don't do that. Don't. If I do that, what will happen? That is a later discussion. If you do anything illegal operation, what will happen? I'll discuss later. But first, learn to follow the rules. So I'll tell you in the same way here. If you say long int, if you say unsigned, then it starts from 0 to 4 trillion. No negative numbers. If you say unsigned, long, then you can store from 0 to 8 followed by 16 zeros. Think of it. 18 zeros, sorry. Such a big number. So please understand the difference between unsigned and signed. Unsigned, you can store from 0 to the numbers, whereas in the signed, you can store negative number. That's the only thing. Okay, don't get. So this is the way the allocation works. Allocation has two types. One is called integer. We call int. Other one is called float. In integer there are 4 types. CHAR, short, long. In the float, there are 3 types: single, double, long double. That's all. This is what totally. Long means 64-bit. 2 power 64 is that big. Sorry, not 8,000, 80,000, sorry. It's 0 to 16 followed by 18 0. Sorry, I think I did a mistake. I think I put it 8. 16. That is 2 power 64. 2 power 64 is 2 power 4 is 16. 2 power 60 is so many zeros. Am I right? 2 power 64. Because short is 8-bit. The character is 8-bit. Short is 16-bit. Long is 32-bit. Long is 64-bit. 2 power 64 is this much. and single is 32-bit, double float is 64-bit, long double is 80-bit. That's it. See, totally, this is what all about allocation. Never about worry about how these are used. That we will discuss later. You will understand while we are doing programming. You will use it, but never get confused about allocation. If I say that allocate, but only thing, beauty, you need to understand the very important feature of this guy, that computer. That is the trick. That is, if I say that char A, B, and C, then what the computer does is, in the memory, it allocates a space for A. It allocates for B, allocates for C. They never clash. It's all different place. Don't worry about where. This is what where you don't have to worry initially. Now it allocates somewhere. I'm not worried about where it allocates. But only thing is, if I tell him, see, if I tell him very clear, see that if I tell the computer, hey, char ABC, A equal to 10, B equal to 20, C is equal to A plus B. Then printf. That's equal to put. I'll explain later. That's why I didn't do that. C. Then what happened? When you say ABC, he allocates in the memory 3 spaces, A, B, and C. You told him put 10 on A, he put 10. You put 20 to B, put 20. Then you add A plus B, he takes A and B, 10 plus 20, 30. Then put it on C, put 30. Then you say print 30. Then you get 30 on the screen. Understand? So I'll show you the thing because somebody have a doubt on the char. So I wanted to show that the thing on the screen, so you will not have this doubt. I'll open a program. I'll share it to you. Then you will not have the doubt. So with the whole C program, we will be dealing with real life problems. We'll see that on the screen. We'll write a program and see that. So don't worry about your doubts. Ask your doubts, all your doubts. So let us get into the. So I use the software called CodeBlock. You can use any software. I use a software called CodeBlock. CodeBlock is a good one, which I use. I open an empty file. I write a program now. This I'll explain to you tomorrow when you're writing programming. Next class. Don't worry about now. People always have a doubt about the first 2 lines. What is this hash include? What is a int main? These 4 lines, don't worry. Don't worry about these 4 lines. I'll explain to you later. Initially, don't worry about these 4 lines. We are going to worry about from here. Char A, B, C. Then I say A equal to 10. B equal to 20. C equal to A plus B. Printf percentage D, C. I put the result. That's it. A small 4 lines program. Don't worry, I'll explain to you these things on the programming session. Okay, the equal to and everything. Today I'm discussing about only allocation. I'll explain to you all these things in the yes, you are right. That is what I'll explain to you now. After this, I'll explain to you that depends on system type. Not depends on the compiler type also. Okay, that's why I always say that either use. After this I'll explain. After showing this program, so I've given character char ABC. I run a program. I compile it. I'll save it now. I'll save the file. I'll save it. I'll save it as a C file. Then I compile it here. This compilation, everything I'll explain to you on the next programming class. Okay, don't worry about that. Now I execute it. See here. I got 30. It's no errors, anything. The compiler given me 0 errors and 0 warnings. No, I want to show somebody had a doubt about CHAI is an integer. I want to prove that CHAI is an integer. Okay, it is not character. Now it's clear. That's why I showed you on the program itself. Okay, so whenever you have a doubt, we write a program. Now I see here. Now I write here A equal to 300. I told you it is not correct. Okay, now I compile it. See that. See, this guy is giving a warning. Overflow the conversion integer to character. That's see that. You cannot do 300 to A. That is not possible. But he has given a warning. Okay, but if you run the program, it will give different value, not 320. You will not get 320, you will get 64. That's a problem. So you get 64, not 320, because 320 is exceeding the limit of CHAR. But same thing if you do here, long, short, it will work. See 320. So the same program, if I do here, things will work. Now if I say here, 70,000. See here, I've written 70,000. Now let us compile it. What happened? See, he's getting overflow. So if I execute it, what I'm getting now, you see. See, 4,484. You're supposed to get 70,000 plus 20. But yeah, that is the trick is overflow. He does not consider. I'll go to the board and tell you now. Okay, let us go to the board. Let's go to the board. I'll explain to you that why it has got 64. No. Unsigned and signed are same. No difference at all. That's a very good question. Somebody has asked, will the unsigned will... No, it's correct. If somebody said unsigned and signed will talk by same space. Now I'll explain to you in detail. Fine, very good. Now the same thing is somebody has asked some very good questions. You see here, this is the way things to be going, interactive. Somebody has asked, will the unsigned and signed will more space? Now you see here, I put 2 characters. Signed char X. Unsigned char Y. Do that, both. Now I say here, now what happened in the memory? In the memory, the space is same for both 8 bits. But now you say here, X is equal to minus 36 and Y equal to 100 and 220. See that. Y is 210, X is minus 36. Now, the beauty is, what is stored there will be same value. Same numbers will be saved. So what I'm trying to explain is that since you have a 8-bit, you can store from, since you have a 8-bit, you can store from 0000 to 111. If you declare this as unsigned, then it's 0 and this is 255. But if you declare as a signed, the same 8-bit X, what is happening is this. trick is like this. From 1000, it goes to 000. Then it goes to 111 here in between. See, it is divided into like this. Then here it's 000. It goes to 011. So this is minus 128. This is 255. This is 0. This is 127. But if you declare the same 8 bits as unsigned, your starting value will be 000. Ending will be 1111. You understand the difference, how we are storing. This is the way we are storing. So this is what exactly happening on your, but if you put unsigned char X, char X, char Y, both will occupy only 8 bit. But very unfortunately, in the case of unsigned, 100 means 128. Am I right? In the case of signed, 100 means minus 128. I'll show you now. I'll show you now on the program, then you will know that very clearly. On the program, if you see that, you'll be surprised to see that how this guy works. I've given here CHAR. Am I right? Yeah. Here unsigned. B. I say A equal to 128. B equal to 128. Am I right? Both I am storing same value. Am I right now? Now let us print now. Let us print now. A equal to percentage D comma A slash n. Printf B equal to percentage D. Those who don't understand, don't worry. We will discuss about all these things in the programming class, all this printf, all this percentage D and everything. Yes, that's correct. That I'll explain you slowly. Okay. So now you see here, I have stored both A and B 128. That means that 128 means 1 followed by 7 zeros. That's what 128. But if you compile and see the result, you'll be surprised. No errors. See that? No errors and no warnings. That you have to see, very important. Now I execute it. See, A equal to minus 128, B is 128. See that? The same number, 128. At one place, it gives you the value of 128, other value. That is what I explained here. I showed here is the thing. Here I showed the thing. This 100 unsigned, it is 128. The same 100 on unsigned value is 128. You have to be very, very careful. These things will be very, very useful when we are doing the embedded system programming. Okay, there it's all going to be controlling the motors and bulbs and everything. There you should not get confused with these things. Okay, so as somebody has asked one more question. What is the about int? Int is sometime taken as a 16-bit, sometime as a 32-bit. But nowadays, mostly 32-bit, except few. So that's why I always don't prefer to use int. Use always long. It's a very good one. It will work on any program. If you use int, if you use turbo C, that assumes as a 16-bit. The int, your GCC accept as 32-bit. Different compiler will take different. So always. But long means always 32-bit. Now think of the other one. Think of the other very important factor. Learn to use in later days. This one. Int underscore 8. Sorry. Int 8 underscore T. Int 16 underscore T. Int 32 underscore T. Int 64 underscore T. Or uint. U means unsigned. Uint 8 underscore T. Uint 16 underscore T. Uint 32 underscore T. Uint 64 underscore T. So you don't have any confusion here if you do this. This is the latest standard. Okay, all ANSI C99 and all the ANSI standards follow only this nowadays. You can build this. Both are right. Here the advantage is like CHAR. The moment you see these numbers, you don't get the confusion. You'll say, oh, 0-bit. That's the advantage now. So please don't get too much of confusion about allocation. Allocation is all about, are you going to allocate integer or real number? Integer means int. Real number means float. We're going to discuss later, not now. Integer had 4 types. 1 byte, 2 byte, 4 byte, and 8 byte. You cannot allocate, in C, you cannot allocate 3 bytes or 5 bytes or anything. This is called CHAR. This is called short. This is called long. This is called long. That's it. And here there are 2 types. One is called signed and unsigned. -2 plus and 0 to max plus max. That's it. Minus minimum to max. That's it. So this make a point. This will be very useful in coming classes. At that time, when you go back and see the video, you will understand. That is, when you have a doubt, have the anyhow. I told you, that by 10 o'clock I'll upload this video. This video is with you. Go and watch it. We have a next class. Tomorrow's class is going to be microprocessor. If you wish, you just attend it. You will get some knowledge, but don't get confused. But this will give you the idea. This will give you the idea of how things work. You can do it later also. As I told you that if you miss it now, you can do it the next microprocessor class also. You can watch. Doesn't matter. This program is going to run over the period of 1 year. Anytime you can watch. But you should know that don't try to learn everything like a buffet. You go to the buffet, don't try to eat to everything. Then you don't eat the very important thing. Now, right now, you have to have a single focus. You know that. You know the single focus. In our stories, olden days stories, they say that when the guru was telling the Sishyas, put the arrow on the bird. Somebody said that I see a forest, a tree and the bird. Somebody say, I see a tree and the bird and the eye. And finally, one guy say, I see only the eye. Then the guru said, they launch the arrow. Same thing here. You're right now. Your mind should be only about C programming. Your mind should be only about C programming. Okay. If you have some idea about C, let me know. I can start sharing the problems from today. Or if you say that you want to learn something more, I'll share it on the next class. Doesn't matter. Don't worry about time. You have to learning is very important. If you are the college student, before you get out of the college, you should master of C programming. Okay. If you are a school student, you can aram se learn it. If you are a working class employee or thing, whenever you have a time, practice it. But this will give you big fortune to you. Because the moment you learn this, you can do wonderful in electronics. When I'm going to send you the link, when I'm going to connect both the C programming and electronics, you'll be surprised that you have not seen so far. So people have not connected the C programming and electronics. You don't, everybody asks me, sir, I'm an easy student. Why should I learn programming? Hey, today electronics is all about software, man. How many of you know that? Okay. So if you have any doubt, you can ask me now. Okay. Tomorrow's class is going to be about microprocessor. Okay. That will give you the idea about, don't worry, all of them are independent classes. That does not depend on anything. You can, without anything, you can understand microprocessor by tomorrow's class. If you don't understand, let me know. You have to be very open mind. Whatever you know, you should forget. Tomorrow we will discuss about microprocessor, and our C programming and C classes will be on the Thursday. I think I've given you the full schedule already. Let us go by the schedule clearly. Don't worry about that. If you really wanted in between, I don't mind. I can able to have a one-on-one or some classes if you have a doubt. Okay. That's no, those who say that I don't understand, that is fine. But don't say that at the end of the session, I don't understand anything. That is not right. That is not right. If you don't understand anything, let us know now.